Hi, my name is Dr. Tishan. In this video, we are going to do some integration with inverse trig functions, and we're going to do 3 examples here. Let's take a look at the formulas for the inverse trig integration. So we're going to integrate some algebra expressions to get the arcsine, the arctangent, or the arcsecant expressions in our answer. So first thing we're going to want to utilize when we're doing our examples here is we need to make a u substitution. When you're dealing with inverse trig integration, when you're dealing with that, you're going to want to let your u equal the square root of the u squared. In other words, you're going to go into the integrand, figure out where the u squared is. For arcsine, arcsecant, it's under the radical here. Okay, arctangent does not have a radical in the denominator, but find the u squared, and your u substitution is going to be find the u squared, take the square root of that, that's what your u will be. So you'll find the u squared, identify the u squared. It's going to be a little bit more obvious in the arcsine and the arctangent output here. The arcsecant, you want to find under the radical, find the u squared, take the square root of that. That's what you're going to let u equal as you start the problem. Let's do our examples over here. So example number 1, we are going to integrate 1 over radical 9 minus 4x squared. So first thing we want to do, we're going to use u substitution. We want to identify where our u squared is. Actually, if you want to look at the format of this integrand, does this look like it's going to yield an arcsine, arctangent, or arcsecant answer? Okay, so if you look at the forms of the integrand, this should look a little bit something like the arcsine output. So what do we want to let u equal? Find the u squared. U squared is right here. Here's our u squared for this problem. So when you take your u substitution, let u equal the square root of the u squared. If u squared is 4x squared, then u is going to be 2x. You're taking the square root of that. Then we want to get our differential, don't we? Differential, so the derivative of 2x is just 2. And then I like to get the dx by itself. I'm going to divide both sides by 2 to get that dx substitution. We're doing an integration by substitution, so we're using the u substitution here. Rewrite the integral, and we have 1 in the numerator. Okay, under the radical here, now we have our 9 minus, and then we're going to substitute in for here, since u is 2x, 4x squared is u squared, we're going to substitute in our u squared, okay? And then our dx, we have du over 2 for the dx substitution, all right? There's a constant. I like to bring the constant out front, okay? I like to bring the constant, if there's a constant involved, I like to bring it out front so it does not get in the way of me seeing exactly what I need to do in application of the formula. So here we go, we have 1/2 out front that we're just going to multiply our answer, and then we have 1 over, and under the radical there is our a squared. 9 is our a squared minus u squared. So let's go ahead, this is an arcsine, it fits exactly in the arcsine form, so you have the 1/2, okay? And then when you do the integration, arcsine, you're going to have arcsine. And we put our u over a. A is the square root of, this is a squared, 9 is a squared, so what is the square root of 9? So u over 3, all right, and then your plus a constant. Don't leave your final answer in terms of u, so it looks like your final answer is going to be 1/2, and then you have arcsine. And then what is u again? It's 2x, so 2x over 3 plus your constant. Okay, so this is how you would apply application of using the arcsine in an inverse trig integration problem, all right? So here's an example with the arcsine, all right? Let's go on to example number 2. 3 over 16 plus 9x squared. That's what we want to integrate for example number 2. So which form do we have here? Well, notice there's no radicals in the denominator. We clearly have an a squared plus a u squared in the denominator. So looks like this one's taken on our tangent rule, all right? So our tangent rule, so as with a lot of integration problems you're going to do in Calculus 1 class, you first want to identify what is u. With inverse trig, go find the u squared. Where is the u squared in the integrand? Here's our u squared, 9x squared, so u is the square root of that. What is the square root of 9x squared? It's 3x. So u is going to be 3x. You want to get your du. So what is the derivative of 3x? It's 3 and then times dx. Your du, your differential. I like to get dx by itself, so du over 3. And there's my dx substitution. All right? So let's go ahead and rewrite this integral so we have the x's in terms of u's, write it in terms of u. It looks like we have a 3 in the numerator. Denominator, we have 16 plus u squared. This is what we're making you're doing integration by substitution, so make the substitution 3x for u, so u squared. And then what is dx? dx substitution will be du over 3, all right? So you see here, our 3's will cancel, all right? right? So we can cancel those 3's out, all right? So we're just integrating 1 over 16 plus u squared, all right? So this is what we've got left over, which is exactly in our form of the integral of 1 over a squared plus u squared. So this is exactly in the form for applying the arctangent rule. So let's go ahead and do that. So apply the arctangent rule. Now arctangent and arcsecant, for that matter, they have 1 over a up front, right? So so a squared is 16. What is a? It's going to be 4. So 1 over 4 arctangent u over 4 plus your constant. And don't leave your answer in terms of u. So one more step. We have 1/4 arctangent. All right, 1/4 arctangent. What is u here? 3x. 3x over 4 plus a constant. So this is how you would do some an integration problem with applying your arctangent formula. All right. So, and know that the notation that is used a lot, but the other notation for inverse trig, okay, is also the tangent inverse notation. So this is another notation that's used quite often. So a lot of times our textbooks use the arctangent, arccosine, arcsine, arcsecant, and so on. But you know, your technology, you have this is the notation on your technology. It's the same thing. Okay, so it is the same thing. All right, and then finally, example number 3. Okay, so example number 3, if you look at the integrand and compare with the 3 on the screen there, it looks like it's going to take on an arcsecant form. Okay, so how do we begin this? This might look a little bit trickier to start, but remember with inverse trig, when you're going to apply an inverse trig application here, you want to look at the integrand, identify what u squared is, find the u squared, and take the square root of the u squared to start, just like we did the others. Find the u squared, your u substitution is a square root of the u squared. Find your u squared, your u substitution is a square root of the u squared. Find the u squared, it's under the radical for the, okay? U squared is x to the 4th, so your u substitution, you're going to take the square root of x to the 4th, and it's going to be x squared, okay? So u is x squared. That's how you want to start this. Identify where u squared is, take the square root, okay? Then we need the differentials. So 2x, take the derivative times dx, all right? I like to go one more step, get dx by itself. So divide out the 2x both sides, just move it over to the other side, and here's my dx substitution, okay? Rewrite the integral, and let's see everything fall right in place, right? So 1 over, we have the x out here, nothing substitutes in for the x, just put the x there, and then under this radical, here's your u squared minus 4. Under the radical, you're replacing this. So u is x squared, this is x to the 4th, u squared minus 4, and then dx is du over 2x, all right? So du over 2x, okay? Now, we need to, u substitution means we need to take the entire integrand and get all the x's out and replace everything with u. You can see that I have an x here and I have an x here. Both are in the denominator, so let's go ahead and combine them and see what happens, okay? So what do we have? Well, we have 1 over, and then, so I'm going to multiply, so 2x squared, okay? And then radical u squared minus 4. And I can't have any x's in the integrand, okay? I don't want any x's in here, so what do you think I would need to do with this x squared right here, okay? So what did I do with x squared? Look up here, and what do you see? X squared, well, x squared is u. We're gonna make that substitution right here. We're gonna call that x squared u. I'm gonna take the 1/2, I'm gonna take the constant, I'm gonna pull it outside the integral so it doesn't get in our way. We're gonna pull the 1/2 out, and then what do we have here? 1 over, instead of x squared, because I need to get the x's out of there, x squared is u. I'm going to have u, radical u squared minus 4. So see, with our u substitution and going through step by step, we have the integrand exactly in the form of 1 over u radical u squared minus a squared. So it's exactly ready to go ahead and apply the arcsecant formula. So we have the 1/2 out front, apply the arcsecant formula. It's 1 over a. We do have a 1 over a up front, so a squared is 4, so 1 over 2, and then arcsecant. Absolute value u over the a is 2, and then plus your constant, and we're not going to leave our answer in terms of u, so let's combine things a little bit here. So your final answer is going to look like this: 1/4 up front, arcsecant. absolute value u is x squared, okay, over 2 and plus your constant. Now, because it's x squared, the absolute value signs, you don't have to have them, right? No matter what value you plug in for x, it's always going to come out positive, but I'll just leave them there for now. So here we go. So here's how you would go through and use the inverse trig formulas for integrating. So you're going to integrate these algebraic expressions to get the inverse trig. So here's your example of an arcsine problem. Here's an example of an arctangent, arcsecant, right? So strategy is just look at the integrand, all right? Look at the integrand. If no other substitutions work and you can identify an a squared plus u squared, or under radical u squared minus a squared minus u squared, then it might be an inverse trig problem, correct? Okay, so the strategy is to go find the u squared, take the square root, that's what u is, and then step by step from there until you finish and get through the problem. Okay, so hope this helps out with your Calc 1, learning how to do some integration with inverse trig functions, and thank you very much. Take care.